Hello students, welcome to MAGESH classes. In this presentation we are going to discuss about +1 chemistry unit 8 physical and chemical equilibrium part 2. In the part 1 we have discussed the question from 1 to 14. In this video we are start from 15 onwards. Let us move into the question part. Question number 15. In the reaction ferric hydroxide in the solid state, equilibrium with ferric ion in aqueous form and with the 3-hydroxyl ion, AH. If the concentration of OH ions is decreased by 1/4 times, then the equilibrium concentration of the Fe3+. The four options, the first one is not changed. So in case of equilibrium constant, we can say it is not changed because equilibrium constant is a constant. So here the question is the equilibrium concentration of the Fe3+ ion. For that we have to write the equilibrium constant for this equation. The given equation is ferric hydroxide, and writing Kc, it is a ratio of concentration of the product, that is Fe3+ ion in aqueous form, hydroxyl ion in the aqueous form upon the ferric hydroxide in the solid form. The concentration of the ferric hydroxide, equilibrium concentration of ferric hydroxide in solid form is equal to 1. So in equilibrium constant expression, it is Fe3 ion in aqueous form and the OH ion concentration in the aqueous form is present. So this is equation 1. In the question, it is decreased by 1/4 times. The hydroxyl ions is decreased by 1/4 times. Now the Kc is equal to Fe3+ ion into 1/4 OH ion concentration power 3. Okay, so this is equal to Fe3 plus 1/4, it is 1/64 into OH ion concentration power 3. This is equation 2. When you decrease the concentration of the OH ions, the Kc will be decreased by 64 times. Okay, so when you compare the equation 1 and 2, it is decreased by 1/64 times. The Kc is constant. That is, equilibrium is a constant. So in order to maintain the constancy, the ferric hydroxide, ferric ions concentration will be increased. Okay, so in order to maintain the constancy of the Kc, the Fe3+ ion concentration is increased by 64 times. Okay, so our answer is D. Question number 17. The equimolar concentration of hydrogen and iodine are heated to equilibrium in a 1 liter flask. What percentage of initial concentration of hydrogen has reacted at equilibrium if the rate constant for both forward and reverse reactions are equal? So in this question, what percentage of initial concentration of hydrogen has reacted at equilibrium? For that, the equation is hydrogen iodide formation, that is hydrogen and iodines are heated to attain the equilibrium. So this is the basic equation. Initially, let us say 1 mole of hydrogen is taken. Initially 1 mole of hydrogen and 1 mole of iodine is taken, and the amount of HI is 0 in the container. The volume of the container is 1 liter. And at equilibrium, the amount of hydrogen is reacted. So this has to be found in the question. Reacted, say X. Here also X dash. Number of moles in the equilibrium. Equilibrium is equal to 1 minus X. Here 1 minus X. Here 2HI. When 1 mole of hydrogen is reacted, you get 1 mole of iodine and 2 moles of HI. So X mole is reacted, you get 2X mole of HI. And equilibrium concentration. Equilibrium concentration is divided by volume. So the same value, 1 minus X, here 2X. So writing Kc for the hydrogen iodide reaction, it is the concentration of HI power 2 divided by concentration of hydrogen into concentration of iodine. By substituting, you get HI concentration is 2X by 2X power 2 divided by 1 minus X into 1 minus X. This is equal to 4X square divided by 1 minus X square. This is Kc. Kc is given in the form of the rate constant for both forward and reverse reactions are equal. Kc is equal to rate constant of the forward reaction divided by rate constant of the backward reaction. So Kf is equal to Kb is given in the question. So Kc is equal to 1. So by substituting the Kc value, 1 is equal to 4x squared divided by 1 minus x squared. The problem is how much amount of hydrogen is reacted in the equilibrium, that is you have to find out the x value. So 4x squared is equal to 1 minus x squared. So this is equal to 4x squared is equal to a squared minus b squared formula. So it is 1 squared plus x squared minus 2x. This is equal to 3x squared is equal to 1 minus 2x. 3x squared plus 2x minus 1 is equal to 0. This equation is solved by method. So 3x squared plus 3x minus x minus 1. Okay, so this is equal to 3x common. So x plus 3 minus 1 into x plus 1. Here it is 1. Factorizing, you get 3x minus 1 and x plus 1. So x is equal to minus 1 or x is equal to 1 by 3. So x may not be 1, so it is 100%. So it is 1 by 3. 1 by 3 in case of percentage, the percentage of x is equal to 1 by 3 into 100. This is equal to 100 by 3 equal to 33.3 percentage 33. So your answer is A. In the equation, the Kc value is calculated. From the Kc, you can find out the x value. The Kc is indirectly given. That is the rate constant for both forward and reverse reactions are given. So K is equal to 1. So from that, you can find out the x. In percentage, it is 33%. Clear? Question number 18. In a chemical equilibrium, the rate constant for the forward reaction is 2.5 into 10 power 2 and the equilibrium constant is 50. The rate constant for the reverse reaction is. So it's a basic question. We know that the Kc is equal to rate constant of the forward reaction by rate constant of the backward reaction. In the problem, it is given Kb is equal to, that is rate constant for the backward reaction. Backward reaction is in the question. Kf is given. That is Kf is equal to 2.5 into 10 power 2. And one more value, the equilibrium constant Kc is given, it is 50. By substituting, you get 50 is equal to Kf by Kb. It is a rate constant of the reverse reaction. So the Kf is 2.5 into 10 power 2. So the Kb is equal to 2.5 into 10 power 2 divided by 50. So this is equal to 250 divided by 50. Is it 5? Our answer is B. Question number 19. Which of the following is not the general characteristics of equilibrium involving the physical process? Equilibrium is possible only in a closed system at a given temperature is a true statement. So only in the closed system the physical process exists, equilibrium. And the second statement, the opposing process occurs at the same rate and there is a dynamic but stable condition. When the equilibrium is considered, the rate of the forward and backward reaction are same, equilibrium is access. So the both forward and backward reaction occurs in the same rate and it is a dynamic but stable condition. So this statement also correct. And the C, all the physical process stop at equilibrium. So it is wrong. Even at equilibrium, both the physical process takes place. That is forward reaction and as well as backward process takes place. So this is not the general characteristics. And all measurable properties of the system remains constant. That is at equilibrium, the temperature, pressure, volume is in the constant condition. So your option is C. Question 20. For the formation of 2 moles of SO3 gas from SO2 and O2, the equilibrium constant is K1. The formation of 2 moles of SO3. In this problem, it is given that the formation of 2 moles of SO3, that is formation of 2 moles of SO3 is given. The value is equilibrium constant is K1. To find out the dissociation of 1 mole of SO3 into a sulfur dioxide into oxygen, you have to find out this K value. So this is a required equation. To find out this equation, the equation 1, say this is a equation 1, this equation is inverted. By reversing the equation 1, what do you get? It is 2SO3 gives 2SO2 plus O2, and the K is equal to 1 by K1. Okay. Then to obtain this dissociation of 1 mole, this equation is divided by 2. By dividing this equation by 2, you get the required equation dissociation of 1 mole of SO2 to SO2 and oxygen. So divided by 2, the K1 value will be root of K1. So this is equal to 1 by K1 of. So this is 1 by K1 of. So our answer is C. Question number 21. Match the equilibria with the corresponding conditions. Liquid equilibrium with vapor, solid is equilibrium with liquid, and solid is equilibrium with vapor, solute is in solute in the solution. The first one, when the liquid is equilibrium with vapor, then it is said to be boiling point. So at boiling point, the vapor pressure of the liquid and vapor pressure of the air, the gaseous form is equal. So the liquid and vapor, it is nothing, it is the boiling point. Okay. And the solid is equilibrates with the vapor of the liquid, then it is called a solid and liquid cases a melting point. So it is nothing, the melting point. So for 1, the boiling point 3. So answer is B or the D. It may be answer B or the D. Okay, so A and C are not the answer. Then solid to vapor, we know that the direct conversion of solid to vapor is called sublimation. So equilibrium is between the vapor and the solid, is called sublimation. So the third case, it is sublimation. So for 3, it is 4. So your answer is the B. Okay. Then solute, solid and solute, it is a saturated solution, and so your answer is B. Question number 22. Consider the following reversible reactions at equilibrium. A plus B gives C. If the concentration of the reactants A and B are doubled, then the equilibrium constant will be. The equilibrium constant is the constant, that is Kc is the concentration ratio of the concentration of product to the concentration of the reactants at the equilibrium condition. This Kc is constant. When the equilibrium constants are altered, what happens? The Kc remains constant. So Kc does not changes. So it is answer is remain the same. The equilibrium constant will remain the same. The equilibrium constant depends upon the temperature only. As temperature increases, it may be increases or decreases depending upon the endothermic or exothermic reaction. So your answer is D. Then question number 23. The complex cobalt aqua complex is pink in color. When it is treated with the chloride ion, it is converted into blue color. Okay. The color change in this equation is pink color is converted into blue color. Okay. In the above reaction at equilibrium, the reaction mixture is blue in color at room temperature. So at room temperature, the color of the complex is room temperature, it is blue in color. On cooling this, that is temperature is lowered, it becomes in the pink color. So at low temperature, it is pink color, and so the reverse reaction is exothermic reaction and forward reaction is endothermic reaction. So one is reverse and another one is opposite in direction. So at room temperature it is blue in color. When temperature is lower, that means the temperature is reduced, it will be pink color. On the basis of the information, which one of the following is true? The first case, A A is delta H is greater than 0, it is the forward reaction. Delta H is equal to, so it depends upon the delta H value, whether it is exothermic or endothermic. So it is a endothermic reaction. Okay. The forward is endo, and so it is endothermic equilibrium reaction. So del H is positive, so it is greater than 0, and it is for the forward reaction. So it is not the answer delta is equal to 0, and del H 0, it is a exothermic reaction. Here it is a endothermic. So our answer is A. Question number 24. The equilibrium constants of the following reactions are the formation of ammonia K1, the formation of nitric oxide K2, the formation of water K3. The equilibrium constant K for the reaction, that is combustion of the ammonia to give nitric and 3H2O. So you have to calculate the K value for this equation from this information. In order to obtain this equation, you have to modify such changes in the equations. Okay. Now first write, this is a required equation. You have to derive, you have to obtain the information from this equation. The first equation is reversed. So get it is 2NH3 gives 3H2 and N2, and so the equilibrium constant is 1 by K1. The second equation has no change because the NO is on the right hand side, and so the equation is as such, it is K2. The third equation is multiplied by 3 to obtain 3 moles of hydrogen in the first case. So it is multiplied by 3. So what is the equilibrium constant for this? It is K3 power 3. So by adding, you get the required equation. So nitrogen, the opposite cancelled, and it is 3 hydrogen, and it is 3 into 1 by 2. So it is, and it is 3 by 2 oxygen and 3 moles of water, and is K3 cube. So to obtain this required equation, these 3 equations are added, so that you get this one. So nitrogen is cancelled, and 3 hydrogen is cancelled, and oxygen 3.5 and 1.5 is 5.5, and the NO and 3H2O. Okay. So the new K is equal to, by adding, the equilibrium constants are multiplied. So 1 by K1, the equations are added, the equilibrium constant values are multiplies, K3 power 3. So this is equal to K2 into K3 power 3 divided by K1. Your option is in the C, K2 into K3 power 3 K1. Question number 25. A 20-liter container at 400 Kelvin contains carbon dioxide at pressure 0.4 atmospheric and an excess of SRO. Neglect the volume of the solid SRO. The volume of the container is now decreased by moving the movable piston bitten in the container. The maximum volume of the container when pressure of carbon dioxide attains its maximum value will be. Given that is strontium carbonate to gives the oxide and carbon dioxide. So by writing the equation SrCO3 in the form of solid, equilibrium with SRO, it is also solid, and a carbon dioxide gas. So writing Kp is equal to partial pressure of SRO into partial pressure of carbon dioxide divided by partial pressure of SrCO3. This is a solid, and this is a solid, and this is a gas. For solid, the value of the partial pressure is 1, and so the Kp is nothing, it is equal to partial pressure of the carbon dioxide. The Kp value is given, the Kp is nothing, the pressure of carbon dioxide is given, and so the Kp is equal to 0.4 atmosphere. Okay, you have to find out the volume of the container when the pressure of carbon dioxide attains the maximum value. You have to find out the volume. First, initially the volume is in the 20 liter. It is compressed by the piston. Okay. To find out the resultant volume, you use the formula P1 V1 T1 P1 V1 by T1 is equal to P2 V2 by T2. Biles. So P1 is given. In the case of P1, the initial 0.04 atmosphere, and the P2 is the Kp value after the equilibrium. It is 1.6 atmosphere P2, and T1 is equal to 400 Kelvin. Here also 400 Kelvin. And V1 here is the 20 liter and V2 is the question what is the liter. So you can substitute this value. So P1 0.4 into 20 divided by 400, this is equal to 1.6 P2, and V2 divided by T2, the same temperature 400. So this cancel will be cancelled. You get 0.4 V2 is equal to 0.4 into 20 divided by 1.6. Okay, so this will be 4. By cancelling, you get 5 liter. 5 liter is the answer. Okay, so in this equation, initially in the container 20 liter volume and having the pressure 0.4, attain the equilibrium, and so the pressure will be Kb. Why it is equal to Kb? That means only the container, the pressure is due to the partial pressure of carbon dioxide, so it is considered as a final pressure. Okay, using Bayes' law, you can find out the volume. Okay, okay students, I hope that it is useful for you. Up to this, we have stopped this presentation. Thank you for watching.